So just to, it's been a long time, it feels like. 3.5 is the end of the chapter. Okay. What I thought I would do today is kind of go through 3.4 and 3.5, both, I mean, problems from both, and then give you a chance to work on 3.4, 3.5 in class. I'll probably do the same tomorrow, and we'll review, because Thursday we're going to have a quiz over 3.3, 3.4, 3.5, those three sections. So today, I'm not going to count it for this quarter. Today I'm just going to kind of review with you guys, let you work, get some help. Tomorrow, same thing. I want you to be able to get help. So things won't be due until the end of the day tomorrow for 3.4, 3.5. Okay? And then we'll do a quiz on 3.3 through 3.5 on Thursday. But that quiz will not count for this quarter, because if anybody doesn't do well, I want you to have an opportunity to do it again. So I don't want to just grade it and then count it. Yeah, so I had training on instructional framework that we're using at school last week for 2 days, and yesterday I had to take Kate to the doctor in Denver. She had a seizure at the end of August, so we're trying to get to the bottom of what's going on with her. Yeah.
That scared me.
So,
I did not know that.
yeah. So, okay. All right. So let's talk about 3.4 first, and we're talking about parallel and perpendicular lines in the coordinate plane. Parallel and perpendicular lines in the coordinate plane. So we are kind of bringing back a little bit Algebra 1. Those who haven't had Algebra 2, definitely bringing back the review that we did in Algebra 2 also. But Algebra 1, we learned graphing equations of lines, right? And the easiest form is called the slope-intercept form, right? Where m is your slope and b is what? Y-intercept. And tell me again what the y-intercept means.
It's where the line crosses the y-axis.
Right, where the line crosses the y-axis. So it doesn't tell us anything about where it crosses the x, but it's just where it crosses the y. So m is the slope, b is your y-intercept. Okay, so in this section, what we're learning is how to find the equations of lines that are parallel or perpendicular to another line. Okay, so normally you're given an equation of a line, and they will ask, what is the equation of the line parallel to this one that goes through the point, I'm making something up, so hopefully it comes out decent, but goes through the point 2,4. Okay, what's the equation of the line parallel to this one that goes through the point 2,4? So the only thing this equation will tell us that's helpful at all is the slope. The y-intercept doesn't really matter. Okay, if I were to graph this line, remember how we graph lines in slope-intercept form. We start at 1, and then we use the slope to find the second point. And we use the slope to find the third point. And we connect them. And there's the line, y equals 3x plus 1. Everybody follow that? If I'm wanting to find the line parallel to this one, the y-intercept here is 1, but my line parallel is not going to have the same y-intercept. So this information does not help me at all in finding a parallel line. The only thing with that equation that helps me is the slope. Okay, so we know something special about two lines that are parallel that has to do with their slope, and what is that?
They have to have the same slope.
They have the same slope. Okay, two lines that are parallel have the same slope. Yes. Okay. Okay. So the slope here is 3. So the slope of my new line has to be y equals 3x plus some unknown that I don't know. We're going to call it b because it fits in with this form. But I don't know what b is. But I do know the slope of a parallel line has to be 3. With me so far? So the trick to finding b, they give us this point for a reason. It's got to go through that point, which means this point is on this line. So what I'm going to do is I'm going to plug in 4 for y, 2 for x, and solve for b. Okay? So that becomes 4 equals 6 plus b, subtract 6, b is equal to negative 2. Now I have the equation of the line that's parallel to this one that goes through 2, 4. Let's just test it out. Negative 2, up 3, over 1. Up 3, over 1. So it's definitely parallel. It has parallel slope. The point 2, 4, 1, 2, 1, 2, 3, 4, that point's on the line. Everybody follow that process? Okay, so the only thing we care about from the original equation is the slope. If it's parallel, we know the new equation is going to have the same slope. And then we have to find that y-intercept by plugging this point in for x and y, solving for b. And that's the algorithm. That means that algorithm is just, that's the process. That's the step-by-step process on finding a line parallel to another line that goes through a given point. Okay? We do the exact same process when we're trying to find something perpendicular. So let's say we want to find the line, the equation of the line that's perpendicular to this one that goes through this point. Okay, perpendicular to this one that goes through this point. So what do we know about two lines that are perpendicular that has to do with their slope? Opposite reciprocal. It's got to be both. You change the sign, you flip it. It can't just be a flip. It can't just be a change in sign. It's got to be both. The opposite sign and the reciprocal. That's the slope of two perpendicular lines. Okay? Yep, perpendicular. This was parallel. Now I'm going to do perpendicular. Okay? So the slope here is 3. So the slope of my new line will be negative 1/3. So I can write, I still don't know this. And it's not the same as this. Okay, don't confuse the y-intercepts of both lines. Don't care about the y-intercept. All we're really looking at is the slope. So I want that point, 2, 4, same exact process. I'm going to plug in 2 and 4, negative 1/3 times 2 plus b. And now I have to solve for b. So I have 4 equals negative 2/3 plus b. So it's 4 plus 2/3 equals b. Well, 4, that's 12/3, right? So that's 14/3. Just getting a common denominator. Okay? So b is 14/3. So the equation of the line perpendicular is negative 1/3 x, the opposite reciprocal slope of the original, plus the b I just solved for, 14/3, which is what? 3 goes into 14, 4, 4 and 2/3, basically. If I were to graph this, I would start at 4 and 2/3, and then I would use the slope, down 1, right, over 3, connect them, and what I just found was the perpendicular line to my original that goes through the point 2, 4. It's a little off because it's a fraction, but you get the idea. Okay, that's section 4, how you find the equations of lines that are parallel to other lines and perpendicular to other lines. If you've got individual questions when I finish, I'll come and help you. Okay, that was 2, 4. 3, 4. Okay. Next section, we are talking about the distance formula and finding the shortest distance from a point to a line. The shortest distance from a point to a given line. Okay? So everything we just did in 3, 4 is going to come to play, plus learning the distance formula. Okay. There are 2 ways you can learn the distance formula. You can memorize a formula and hope that it sticks with you by the time you need it, or conceptually figure out what it's really saying. Okay, so I'm going to show you how to basically come up with the distance formula on your own. So if you forget it, you can recreate it. Okay? And I guess I'm going to use red. So let's just pick 2 points. If I want to find the distance between these 2 points, my advice, draw a right triangle. Draw a right triangle where this is the distance in the x direction, this is the distance in the y, this is the distance between the 2 points. You follow my logic so far? Okay? And I'm going to label this, it's a right triangle. Okay, we're going to learn the Pythagorean theorem again in chapter 8. but you have already been exposed to it at some point in your career so far. And it is, or let's do a squared plus b squared. Just make it simple. Everybody seen that before? Okay. It only works in right triangles. And we're going to have a whole chapter on right triangles. Chapter 8 is the best chapter ever. Okay? Not for me. I love trig, though. And but it's just the beginning of trig. I love trigonometry. No. Okay, a squared plus b squared is c squared. This is a, this is b, this is c. C is always the hypotenuse. Hypotenuse is the side opposite the 90-degree angle. Okay, C is always the hypotenuse. So, if I'm looking at this triangle, and I look and I count the distance, this is 3 units, right? And I count the distance, 5 units, then I can just plug it in. 3 squared plus 5 squared equals c squared. Are you with me so far? 3 squared is 9. 5 squared is 25. 9 plus 25 is 34. So c is equal to the square root of 34. That's the distance. Okay? Now, if you want the formula for the distance formula, it's this point minus this point. So they call that, okay, this point minus this point, which is 3 for us. This point minus this point, and that's equal to the distance squared. That's the distance formula. So the distance, let's call this d, is the square root of this whole mess. But that's what we did. We found the distance from here to here and labeled it 3. We found the distance from here to here and labeled it 5. This piece was 3, this piece is 5, this was c squared, and then we took the square root of 34. Okay, so you can memorize it's the square root of x2 minus x1 squared plus y2 minus y1 squared, or just draw a triangle and use the Pythagorean theorem. That's the easiest in my opinion. Okay? Yeah. Okay, so the distance. What isn't everybody, if you have a whiteboard, this is 0.23, and this is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Find the distance between these 2 points. You need a whiteboard? Everybody have a pen that works? Okay, find the distance between those 2 points using the triangle method.
Is that 7, 5?
Yeah, 7, 5. Yeah. Well, just, I mean, I guess use whatever method you can remember.
So is A always going to be the bottom, or is it A the shortest side?
It doesn't matter.
Okay.
A and B don't matter which side
yeah,
you pick.
yes.
C does. C has to be the hypotenuse. Remember, the distance between the 2 points is always the hypotenuse of your right triangle.
Opposite of the 90.
Mm-hmm.
And then it doesn't matter which way it is.
Yeah, whether your triangle is right side up or upside down doesn't matter,
Grab me one.
as long as
Thank you.
the hypotenuse is your C.
I don't even have to look for the buttons on the calculator anymore. It's just basically muscle memory.
Nice.
I think that's Algebra 2's fault.
Yes.
Do we go 2 or 10?
Darn Algebra 2, teaching your calculator. What's
Do we
that?
go to the 10s?
I'd like you to leave it in radical form.
Oh, crap.
Radical form is the most precise.
I've
So So unless the problem asks for round it to 2 decimal places or round it to a tenth, leave it as a radical.
I have both of them.
Both sides
Right now, it's
and C is the hypotenuse.
No, you won't.
Everybody have a chance to do it?
No, it's the square root of 29.
I'm not doing that.
Yeah, I know. I'm saying you're wrong. It's the square root of 29, not the square root of 29.
Squared.
Okay. So if I'm going to draw a triangle, that's mine. It is perfectly fine to draw that too. You're going to get the same answer. Okay? So, on my triangle, I know 1, 2, 3, 4, this is 5, this is 2. So I take 2 squared plus 5 squared is equal to, I don't know, just call this x. What I'm looking for, the distance.
I just call it C squared.
4 plus 25 is x squared. So x is the square root of 29. That's it. That's the distance. Okay? Use the equation, use the triangle method, but you have a better shot at remembering the triangle method than you do the equation.
The distance one is just if they give you points instead of using the triangle method. So like if you're
Yeah, so if I have the point 2, 3 and the point 7, 5, and I use the distance formula, x2 minus x1 squared, y2 minus y1 squared, same thing. Okay? Sometimes just helps to visualize it. That's how the distance formula was derived with the Pythagorean theorem.
Give us another.
One more.
One more?
Let's have some fun.
No.
I'm doing one more.
Have some fun.
Okay, this time I'll just give you 2 points.
Yeah. Word problems.
I can't draw straight lines.
I'll just give you the points. You can choose. Do you want to put them on a grid and draw your triangle, or do you want to just use the formula? It's up to you.
Triangles, same thing.
Triangles are cool. Wow. No, we got this.
It's a very skinny triangle.
Got it.
Two, three, four, 5. 2, 1, 2, 3, 4. Something like that. So this is 1, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, distance formula. Everybody understanding the distance formula? Okay, so let's move on now to the reason that we want to learn the distance formula. And this is going to combine the distance formula from 3.5 with what we know about parallel and perpendicular lines in 3.4. Okay, and what we're going to do, I'm going to just pick one from the book so I make sure it's a good one. What's the question? 1, 5, 1/3 x minus 2. Okay. This question wants to know what's the shortest distance from this point to the given line. The shortest distance. So the first thing you need to understand in order to solve this problem is the shortest distance from a point to a line is the perpendicular distance. The shortest distance from a point to a line is the perpendicular distance. So if I graph this line, start at -2, and I use up 1 over 3, up 1 over 3. I'm still not perfect with my line, but close enough. There's my line. My point is 1, 5. 1, 1, 2, 3, 4, 5. So conceptually, what they're asking is, what is the shortest distance from this point to this line? Do you see that I could draw all kinds of lines to this line? They're all going to have different distances. But if I want to find the shortest distance, it's got to be the line that's perpendicular to this line. Okay, so it has to be the line perpendicular to this line. Now, there are two ways. There's an easy way to do this, and there's a more complicated way to do this. And why would you use the more complicated way? Well, you'd use the more complicated way if when you are using the slope, you don't end up at exactly an intersection. It ends up being a fraction, so you have to know exactly what it is. You can't just guess from your drawing. You're going to have to know the complicated way to do that. Okay? But what I'm going to do is talk you through the easy way first, because you can always try that, and if it ends up working, then you can skip the complicated way. Okay? So what we're going to do, if we know the line that goes from this point to this line is perpendicular, what do we know about their slopes?
They're going to be the exact opposite, so it's going to be -3.
Opposite sign and reciprocal. Both. Right? So Caleb, as you said, the slope of the line that goes from here to here is going to be -3, because this slope is 1/3. Does everybody see that? Okay, so if I know the slope is going to be -3, this is the easy way. I can start here, and I can use -3 for my slope, and go down and see where it intersects this line. And if it intersects at a coordinate that's very easy for me to see, then I'm done. I can find the line. Okay, so I'm going to start. I'm going to use -3. Down 3 over 1. Down 3 over 1. There's where it intersects. Okay? Didn't do that very well. So there's the line. Now I need to find the equation. Well, I have the slope. So I can use the same thing I did. I know this is my intersection point. So I know this point's on it. Right? It's going to go through at that point. So I can use this point, 1, 2, 3, -1, to plug in for x and y. Or, to do it a little easier, if it works, I'm showing you the easy way, if it works, I'm going to use the slope up 3 to the right, left 1, right? That's the same as -3. If I go up 3 and then left 1, or down 3 and right 1, I still get -3, right? When I do that, I can see this point is 1, 2, 3, 4, 5, 6, 7, 8. Well, that's my y-intercept. So I don't even have to plug x and y in, if it works.
Can you also solve it with the other?
Yes. Yep, and you should get, if you use this point or this point, you should get that equation. That's the easy way, is just counting the grids. Using the slope and counting the grids until you find intersection points.
I remember really not being good at this in algebra 2.
Okay, I'm going to go through the algebra way now, which is what you're going to have to do if my system doesn't give you an exact coordinate. Okay, the algebra way. Yeah. Let's find a different one. Let's do this. Let's do, we're going to do distance between two lines. Y equals 2x plus 4, y equals 2x minus 1. This time, do you recognize these two lines are parallel?
Nope.
Yes.
Yeah, because they have the same slope. Okay, so I'm going to just draw them real quickly. -1 up 2 over 1. And then 4. 1, 2, 3, 4. Up 2 over 1. Okay, my two parallel lines. They want to know the shortest distance between them. The shortest distance between them. I didn't even get to that answer on the last problem, I just realized. All I did was find the equation of the line. So we'll go through the whole process with this one. The shortest distance between them. Now, if I were to just draw perpendicular lines all the way through, I have an infinite number I could choose. Does everybody agree there? Yes. So I don't really care what there's no the equation of the distance between them because there's tons of equations. They will all be parallel too because they're all perpendicular to those two. But what I want to do is find an equation that I can use to find the distance between the two. So I'm going to find the equation, figure out where it intersects the other line, and then use the distance formula to find the distance. Okay, my hint in doing this when you have two parallel lines, start at an intercept. Either that one or this one. Start at an intercept when you're doing this process. Okay, so what do I know about the line going through this point that is perpendicular to these two lines? What's the slope? -1/2, right? And I'm going to use that y-intercept. So I'm going to use a line that goes through this point. And it's going to go down 1 over 2. So there's my intersection. It's perpendicular to both of those. Okay, now I can make my triangle.
What?
I'm finding the distance. This is 1, this is 2. The distance between them is the square root of 5.
Oh, I get it. I get it.
And it'll be the square root of 5 no matter where I draw my line, but it's the square root of 5. Now, well, that wasn't the hard way yet. Now I'm getting to. Let's pretend that I could not just count down and over 2, and I don't know what this point is. Okay, let's pretend when I counted over down 1 and over 2, that point was a fraction, and I couldn't tell precisely what it was. What's that? Well, now I've got this equation, and I want to figure out where this equation, the perpendicular line, intersects with this one. Nope. I want to figure out where it intersects with this one. So which one of these two is the equation of the bottom line? The bottom one. Okay? So where those two intersect, where they're equal to each other, is where that point is. So what I have to do algebraically is I have to set this equation equal to this one. Because where those two are equal is where they intersect. Okay? So I'm going to say 2x minus 1 is -1/2x plus 4. Okay? I have to be careful and pick the right line because I'm trying to find this point of intersection. So I have to use those two lines that are represented by that equation. Okay? What I would probably do here, because I love fractions, but you probably don't. Just kidding, I don't like them either. Is multiply by 2, just to get rid of it. So I get 4x minus 2 equals -x plus 8, right? The 1/2. Then I just don't have to deal with it. So did everybody see 2 times -1/2 is just -1? Yeah. With this strategy, it's an awesome strategy, but you have to make sure and multiply every term by that number and not skip any one of them.
Multiply by what?
2. The denominator. So I can get rid of it. Okay, now it's easy to solve. 5x equals 10. X equals 2. So I know the x coordinate of that intersection point is 2. Now all I have to do is plug 2 back into either one of these equations. So I'll just do it here. 4 minus 1, or 2 times x is, 4 minus 1 is 3. So my point should be 2, 3. So let's go back and look and see how I did. 1, 2, 1, 2, 3. No, but it's harder than just counting. If you can't just count the squares and figure out that coordinate point, you've got to use this method where you set the two equations equal and then solve for x and y. You don't have to, well, I don't know how you do it without visually seeing what you're trying to work with, though.
Cole's just a genius.
But if you can do it without seeing it, then, unless the problem says graph, then you're going to have to.
Just make a movie off topic.
We should all.
You'd actually nail it. That'd be literally favorite.
Okay, do you want me to give you a problem to try real quick?
Yeah.
Probably a good idea.
Okay.
Before we start messing up on our actual thing.
Okay. Let's do,
Why?
those are all perpendicular parallel. I wonder if it's in this. Yes, it is. Okay, let's do determine the shortest distance between these two lines. I want to make sure I get something that makes you have to do a little. Okay, determine the shortest distance between these two lines. Everybody give it a go.
No. Nice. I forgot everything you just said.
That's why we're practicing.
Oh, wait. You have to find the perpendicular line first.
I'm going to give you just a couple more minutes, and then I'll go through it because I want to be able to go through this problem before the bell rings. Distance formula.
Figure it out. I'm kind of retarded when it comes to math, but see where this goes.
Yeah.
Would you prefer it in a decimal or no? Okay. Gotta make sure it don't.
Alright, well, that's
I got this one.
This is how you do it. Thank you.
So you go like 3, x equals 3.
What? No,
1, 2, 3, 4, 5, 6, 7, 8.
And but it is going to be
1, 2,
3
3.
x. I chose plus 2. I do go on, with 3x plus 2. Just grab one from there. And then you have your triangle set up in the center, and then it's the Pythagorean.
So you go 3 over 3 over 1.
Okay,
3 over 1.
there are my two parallel lines, sort of. Okay, so the perpendicular slope will be positive 3, right? So I'm just going to start at a y-intercept. I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. There's my point of intersection. So luckily I don't have to set my two equations equal here. Okay, so that's the line that's perpendicular to both. And I'm trying to find this distance. Because that's the perpendicular distance between them. So I could either use the points and plug them into the formula, or I just draw my triangle. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So it's the square root of 81 plus 9, which is the square root of 90. I should simplify this, but we haven't talked about how to reduce radicals in this class. You guys should know it, but I mean, this technically is 3 squares of 10.
Oh, no, I didn't do that.
But the square root of 90 will give you the right answer here.
Yeah, I have no idea. I don't remember how to get 3 roots of 10.
Yeah. Well, the bell's going to ring in about 2 minutes. So tomorrow, what I would ask that you do tonight
I didn't get 3.
is do as much as you can yourself on 3, 4, and 3, 5. So that tomorrow is just a day of questions for you. You're not actually having to do it for the first time tomorrow. You've already tried it, you figured out what you're not getting, and then we can reinforce what you're not getting so that you understand it tomorrow.
You know, this eraser is almost better without the back.
Okay? And then there'll be a quiz on Thursday.
Eraser Rolo?
Where's my pencil?
Red sun.
I really don't.
It's been here for the last 5 days.